Now we change in steps wavelengths, and we see that wavelength changes, and there is some dead hair, but then it switches off. Dead hair is off now. Switch on dead hair, and then we have permanently waves. Otherwise it's only used to go to new wavelength. Now we change by 3 GHz into one side, and afterward change back by 3 GHz. And the laser is thermally stabilized probably, so it takes some time to move the wavelengths, and we can scan across the absorption line of acetylene. How to control TLX1 laser. That it jumps 4 GHz. Here is the program. We set channel to 79 and use new line symbol, enter, and then is a cycle from start frequency to stop frequency, comparison, and send the string to laser. And here we set the frequency values, start, stop, and step. RS232 signal cable, and the cable was checked with a jumper between pins 2 and 3, that the wires are crossed. We are jumping 4 GHz, minus 2 GHz to plus 2 GHz around the center position of acetylene line at 1534 nanometers. And jump happens every 10 seconds, and dead herring is on. We test the cell with 30 millibars. Lines from 30 millibar cell. Almost 100%, yeah, 100% absorption. Acetylene cell. Valve and pressure meter and for filling, and here it is closed. Now we filled acetylene cell 9 millibars, and yeah, it's too long. Now we have 1 millibar in the cell. We pumped out some acetylene, and the line is no more 100% absorption. And this is with dead hair, and now it will be without dead hair. Duration setup. We have a mirror in the back. Now we have 1 millibar in the cell, and this is modulation. Sweep across line. Pressure in acetylene cell is about 1 millibar. That's the narrowest one which we can get, and absorption is about 40%.